This is a preview of Chapter 2 in CIST 2451, the Cisco course. This chapter is going through and introducing you to how to configure your routers, your Cisco router specifically, and how to go in and do these configurations. And they introduce you to a number of items in the chapter, but it is introducing it specifically to that. You have a lab to do that you'll use Packet Tracer to use, where you'll set up your routers and configure them there. And the directions with the Packet Tracer Lab, which is in the online curriculum in pages at the netacad.com site. There's a demonstration that I do of the similar stuff that is also in Angel that is called Demo of Packet Tracer, and I would strongly encourage you to watch that, where I go through and show you how to use Packet Tracer and do the basic configurations. It's actually out of Chapter 11, out of the old Cisco 1 textbook, but we introduce this to you now in Chapter 2. I'm going to go through the key terms for you in here real briefly and tell you about them and tell you about what you're looking at. The operating system you'll be using on the Cisco devices is the Cisco Internet Work Operating System, or that they'll usually refer to it as iOS. It's basically a Unix-based system, but it is a very limited system, so it doesn't have a lot of things that are available to you in Unix. But if you know Unix or have worked with Unix or Linux, some of it will be recognizable to you, but it is very specifically oriented to the routers and switches. You have in the iOS, primarily you're going to be using command line interface, which is CLI, which many of you are going to go, ooh, that's way backwards and everything. It's basically where you've kept being introduced to about the DOS command prompt in Windows, and about where you could do things at the command prompt there, and back, some of you can remember of doing stuff back into DOS, of it's doing it that way. Instead of using a GUI, although that is available on a limited extent on the new routers from Cisco, but they still strongly encourage you to use the CLI. The GUI is GUI, as graphical user interface, and that's what all of y'all are used to. That's what Windows is. Windows uses a graphical user interface, and on that. You're going to see several different types of memory mentioned in there, but the flash memory is where the primary memory storage is for the routers and switches now. It's actually removable flash memory, just like you use in your cameras and cell phones and other devices. On the older Cisco devices, it was flash memory that was built inside the routers and switches. Now it's actually the same little memory cards of about that size that you're used to. They're the large memory size flash memory cards, but your information, your configurations is stored in flash memory on that flash card. You also do have random access memory obviously in there, which is the RAM, which is the temporary storage area for whatever you're working, which configuration is currently using is going to be stored in RAM. The stored version is stored on flash memory, and that when you save it from RAM to flash. Terminal emulation is going to be the way you're going to go into the router and switch to set the configurations, and that you're going to use a terminal emulation package to do that. Although with Packet Tracer, you're usually going straight into the device and not having to go through a computer attached to it, because you can get straight into it. However, normally out there with your routers and switches, you would use a terminal emulation package to connect in, and you'd go through using a rollover cable connected to the port on the console port on the router or switch, and then you'd use a terminal emulation package to connect, and that your PC is a terminal attached to the router or switch. There is several different modes that you're going to have available to you when you go into the router, and we're talking about routers here, but we'll talk about switches later on, and they're going to work similar. But you've got a user executive mode and you've got a privileged executive mode. The user executive mode is the mode that you go in initially, and that all you can do in there basically is look at stuff. You can't change anything. Privileged executive mode will be when you go in, and that you'll be able to change things, and you actually have to type in command to move up to the privileged exec mode, and then you'll be able to do things. Your prompt, and when you're in user executive mode, will be the greater than sign. When you go into privileged executive mode, your prompt will change to a number sign. And so that you'll go in and use that accordingly on there. So your prompt will give you an indication of which level you're on. But to get to privileged executive mode, you'll type in enable, and actually you can abbreviate most commands on the configuration commands to 3 letters. You have to put in enough letters that it makes it unique that that's that command, and you don't have to go any further than that, and it will figure it out from there. So enable can be typed in as ENA normally. There's global configuration mode, which is where you go to beyond privileged executive mode. You got to be in privileged executive mode first, and then you go into the actual global configuration mode, and you go into specific configuration. And at that point, that it then puts the parentheses out there telling you you're in config, and that you'll do config T to get into global configuration mode once you're at a privileged. And then you can actually type in these configuration commands. Ping is just a command for you to be able to see if you've got connectivity between devices. You can use that on your Windows machines too, and that you can go to command prompt and do a ping to an address and see if you can actually contact with it. Now, in the real world out there, when you ping to certain places on the internet, quite often it will get blocked because ping has been abused, and that's the source of attacks, sometimes denial of service attacks that are done on networks, is using pings where your program's written that just throws an excessive number of pings at a device, and that is a high priority item, and that it doesn't do anything else till it answers the ping. And so if there's a ton of pings set at it, it won't do anything else except answer those pings, and effectively locks down the machine and the network. And so quite often you have firewalls and other things blocking pings from coming in on them nowadays. Traceroute actually uses pings, but it is a command there, and that on these devices it is trace RT in the Cisco, and what it does is it tells you every router that you pass through going from whatever you sent the command from to wherever you're trying to figure out the route there. So you can see which routers that you actually pass through on the way there. It will come back and give you that. Now, it is trace RT on the iOS system. If you were actually doing it on Unix, it actually is trace ROUT. So you'll see both ways. When you do enable, that normally when you set up enable, because that's where you can change things, you want to make that password protected. So when you set it up in the configuration, you'll normally say enable and tell it a password the person has to use. The only problem with that is that if somebody does come in and prints out the configuration, they'll actually see the actual password because they'll print it out in plain text. If you do enable secret and the password, what it will do when it prints out the configuration, it tells you that it is using a password and that it's a secret password, and it'll give you the password, but it encodes it so you won't recognize it. Voice over IP you find quite often used out there. You won't be doing that in this chapter, but they mention it to you about that's available to be set up. The college went to using voice over IP last semester, so that when you call us on our phones, that they're actually going through the internet on it, and we actually have the capability talking to other people within the college to view each other talking on the phone. Vonage is also voice over IP that many of y'all are using, and that there's other voice over IP systems out there too that individuals do use. You will be using an IP version 4 address in this chapter. They will supply that information to you, but we'll look at IP version 6 later in the book also, along with IP version 4 more in detail, but they're going to give you an IP version 4 address to use. What that is an address that's got 4 numbers to it that are separated by periods. Looks like something like 192.168.3.1. Each of the numbers can range from 0 to 255. There's a subnet mask that's assigned to that, and what that does is that says what portion of that IP address we just mentioned is actually on the network portion of the address, and which portion is the specific device on the network. We'll look at that in more detail as we look later in the book. The domain name system is just your ability to type in words on your web browser to find places that you don't have to know what the IP address is. You know what the domain name is. For instance, if you want to go to my website, I own the domain name dwightwatt.com. So you can go to www.dwightwatt.com. Actually, you can drop the www because that's assumed if we don't tell it. That's telling it which specific machine on the domain. And what happens is DNS, or domain name system, looks up that name and looks to see what's the IP address associated with it. And there's some IP address associated with my domain name. I'm not exactly sure what it is, but I think it starts with 162 point something. You could actually ping dwightwatt.com and it'll come back and tell you what the IP address is for dwightwatt.com. And it's sitting on a machine in Western Canada because that's where I rent hosting space for dwightwatt.com. DHCP is the ability, instead of having to put an IP address in each machine that you have, that you let it be assigned by a server within the network, and that it assigns out an IP address for that specific machine. So it's an automatic addressing. We use that here at the college. We also quite often, you usually are using it at home too. Your ISP, your internet provider, usually supplies the IP address to your router, and then your router uses DHCP off of it to supply the address to your individual machine. Usually address like 192.168 something, or it could be a 172 address or a 10 address. Those are public available addresses that aren't specifically assigned out. The loopback address is also where we can set up on our router. Besides setting up Ethernet ports on it, we can also set up ports on it that are imaginary ports, which are loopback addresses. That gives us the ability to try an address and make sure it's working correctly without attaching something physically there. You can also do loopback on your individual PCs. What that does is allows you to see, is your network card actually working, that you can do on that, and that it's got an address of 127.something.something.something. Usually 127.0.0.1 is what we reference as the loopback address. This has been a quick overview for you of Chapter 2 in Cisco.